Our topic is domain and the range of the different polynomials functions regarding AS level for P1. So we are going to define each values for the domain and the range of this function there. So first of all, let's define the function that y is a function of x. Then this x is known as to be called domain and this y is known as to be called range. And if we make x as subject for the inverse of this function, then x is equal to f inverse of y, then x will be the range and y will be the domain. So this is basically defined for these two functions. Let's say it is x, it is y, there is a function f. So this will be the domain and this will be the range. All possible values of x which you can get and put into the equations and you get the values of y, then it is known as the x value is known as we call the domain and the y values are known as the values which you get after putting x. So if you take the inverse of this function, it should be equal to this is domain and this one would be range there. So this is the property which we are going to define for this domain and the range of all these functions. Now, first of all, this example one, f of x is equal to, let's say it is equal to y, and that thing is equal to 2x. Because its highest power is 1, so it is an odd number. So first of all, we define this thing as axn, where n is the highest power and a is the value of the coefficient of highest power. Since n is equal to 1 in the first case and a value is equal to 2, which is greater than 0, so the ends of the graphs are in opposite direction and the a value there is, if a is greater than 0, then its right end will be upward and the left end will be downward. So we are going to solve this using this property that the graph of this will be, the domain of this will be belongs to all real numbers, which is denoted by r. So whatever the value of x you can put into this equation, you will get the values of y there. So domain is what all real numbers and the range of this function is also belonging to all real numbers. So both have the domain as real numbers and the range as real numbers when it is a general polynomial of x there. So if we look at the graph of this, then this is the graph of this. It is O, it is Y, it is X, and this is the line Y is equal to 2x. So you have seen it there. Then the right hand is upward and the left hand is downward. So this is question number one, for which domain is all real numbers and the range is also what all real numbers. Now we take the second case when f of x is equal to minus 3x plus 1. Since it is 1 there, so highest power is 1, which is an odd, and a value is equal to minus 3, which is less than 0. So left hand will be upward and the right hand will be downward. And the domain of this function will be equal to is all real numbers. But here they have restricted here. The domain is from -2 to 3. So let's say it is -2, and let's say this value is 3 here. Now you have to put get the values of this domain is already defined here, which is from -2 to 3 value there. So the range of this will be, if you put x -2 there, then y value is equal to -3 into -2 plus 1. So that is 6 plus 1 is 7. So for -2 the value is 7 there. If you put y is equal to 3 in it, then -3 into 3 plus 1, that is equal to -9 plus 1 -8. So that is the value of this -3 plus 3, there is -8 here. So the range of this graph will be y is greater than or equal to -8 less than or equal to 7 there. So this is the range of this graph, and this is the domain of this graph, which is already mentioned there. Now, question number 3. Y is equal to f of x, and that thing is equal to 2x square minus x minus 3. Now, you are going to get first domain and the range of this graph here. We know that the domain of this function is possible for all real values of x. Whenever it is general polynomial, it is all values of x are possible in that equation there. And as far as the range is concerned, now we know that the vertex of this will be h and k there, where h value is equal to minus b over 2a, and k value there is equal to f of h, where this is the value of a there, this is the value of b there, and this is the value of c there. So for this h value there is minus b, that is plus 1 over 2 into a is 2, so that is equal to 1 by 4. And the k value there is equal to f of h, so 2 into 1 over 4 square minus 1 over 4 minus 3. So that value is equal to 2 by 16, that is equal to 1 by 8 minus 1 by 4 minus 3. If you take LCM as 8, it should be equal to 1 minus 2 minus 24, that is minus 26 plus 1, that is equal to minus 25 over 8. So the vertex of this quadrant will be equal to h, that value is 1 over 2, sorry, 1 over 4, and the k value there is minus 25 over 8. So you draw this graph, it is 1 over 4, and this is minus 25 over 8. So this is the vertex, because the coefficient of x squared is positive. So when is the power is even, so when n is an even power, that is equal to 2, then both ends of the graph will be upward. So from this is the vertex, so both ends of this graph will be upward. So it is like this. So the range of this one's more than or equal to the lowest value of that minus 25 over 8. So we can write this word as range is greater than or equal to minus 25 over 8. Now the third question is fourth. f of x is equal to minus 3x squared plus x plus 2. So domain of this function is belonging to all real numbers because it is a general polynomial and the range we will get it now. So range is on the vertex h and k there, where h value is equal to minus b over 2a and f of h is equal to k value there, where this is the value of a, this is the value of b, and this is the value of c. So that is equal to minus 1 over 2 into a is minus 3, and that is equal to 1 over 6. So h value is 1 over 6 there. Now we get the value of k there, which is minus 3, 1 over 6 square plus 1 over 6 plus 2, which is equal to minus 3 over 36. So minus 1 over 12 plus 1 over 6 plus 2. We will take the LCM as 12, then it is minus 1 plus 2 plus 24. Or that value is equal to 26 minus 1, 25 over 12. So the h in vertex is h and k here, which is basically equal to h value is equal to 1 over 6 and k value there is 25 over 12. So x is positive, y is positive, so it lies in the first quadrant. Since the coefficient of x is negative 3, so if a value is equal to minus 3, which is less than 0, then both ends of this graph will be downward. So this is the vertex, so both ends will be downward to that graph, and this is the highest value that, so the range of this graph will be less than or equal to 25 over 12. So this is the domain and this is the range of this graph there. So that is question number 4 we have solved it for this point. Now for the fifth, f of x is equal to 2x cube plus 1. So n is equal to 3, which is odd number, and a is equal to 2, which is greater than 0. So when it is odd and a is greater than 2, then the right side of this graph is upward and the left side of this graph is downward to that graph. So we have drawn the graph of this. There is one there. It is like this. So right side is upward, left side is downward. So domain of this graph is all real numbers, because whenever it is a general polynomial, the domain is what? All real numbers. Whatever you put the values of x, you can get the value of y there. And the range is also belonging to what? All real numbers, because for positive it is positive, for negative it is negative. So there's no restriction on it. So the domain is also real numbers and the range is also what? Real numbers there. Then question number 5, 6. F of x is equal to minus 3x cube minus 1. Here n is equal to 3 and a is equal to minus 3, which is less than 0. So when n is odd and a is less than 0, then the right side will be downward and the left side will be upward to that graph there. So this is the graph, this is minus 1 and it is minus 3 is the coefficient. So left side is upward and the right side is downward to that graph. So the domain is what all real numbers, and the range of this graph is also all real numbers. So whatever you put the values of x as positive, then it gives the negative values to that. When you put negative values, it is positive. But it is belonging to what? All real numbers for this graph here. So domain is what? All real numbers, and the range is also what? All real numbers. Now, question number 7. F of x is equal to x minus 1 square root. Now, we are going to get the domain there. For this domain, this x minus 1 should be greater than or equal to 0 because it is the square root. So remember one thing, that whenever f of x is the square root of that function, then n is either odd or even. If it is odd, then the domain is all real numbers, and if it is even, then it is restricted there. We get the values of this domain there. So this is x minus 1 power 1 over 2. So n is here odd. So even number there. So even number means that the range is not restricted. So that means what, for this value f of x should be greater than or equal to 0 inside of that square root function here. So x minus 1 is greater than or equal to 0 or so domain is x minus 1 is greater than or equal to 0 or x is greater than or equal to 1. So this is the domain of this function here. And now you have to find out the range of this function. Because this graph is like this. It is origin, it is y-axis, it is x-axis, and it is from 1 and it is going to like this. So it means you have seen it there that the range is greater than or equal to 0 value there because range is the values of y and y values are always greater than or equal to 0 to that. Now, question number 8. F of x is equal to x square minus 4 square root, which you can write this thing as x square minus 4 power 1 by 2. So here n is even number there. So first of all, we have to show that x square minus 4 should be greater than or equal to 0. So this is x minus 2, if you factorize it, x plus 2 is greater than or equal to 0. And if you write this critical solution for this, then x minus 2 into x plus 2 is equal to 0. Then x value is 2 and minus 2. So this means the graph of this will be from minus 2 till 2 there. And when you put the domain, so it should be the domain of this function. For this values of x should not be equal to 2 and x should not be equal to minus 2 there. So the domain of this function is minus 2 and 2. So the coefficient of this one is 1. So it is downward upward to that graph. So this is the graph of y is equal to x square minus 4. So because now this have calculated that it should be greater than or equal to 0. So either it will be greater than 0 after this value of 2, and less than 0 after this value of, before this value of minus 2. So domain will be equal to x greater than or equal to 2 or x less than or equal to minus 2. And if we have to get the range of this function, then the range of this function is greater than or equal to 0 there. Because when you put 2, it is 0, minus 2, it is 0, and after that and before that, all the values are positive. So it should be greater than or equal to 0. Or you can just write the range that it is from 0 till minus infinity and 0 till plus infinity here. So you can write in the simple words 0 till negative infinity union 0 with positive infinity. So it is going towards left side and the right side of this graph here. Well, question number 9. F of x is equal to 2x minus 1 square root, which you can write it as 2x minus 1 power half. So you know that f of x should be greater than or equal to, let's say it is new function g of x, which is inside of the square root. So we know that for this domain g of x should be greater than or equal to 0. So that means what 2x minus 1 is greater than or equal to 0, or x is greater than or equal to half. So it is x is greater than or equal to half is the value of this domain for this function f of x is equal to 2x minus 1. And for this range, it should be greater than 0 there. So whatever the value is more than half you put or half you put, you get always either you get 0 or you get more than 0 to this value of this function here. So range is the value of y there. So range is greater than or equal to 0. Now question number 10. F of x is equal to square root of, so the cubic root of x square plus 1 cube root. So this can be written in the form of x square plus 1 power 1 by 3. So we know that if it is f of x n there, where n is an odd number, which is 3 here. So we know that for this cubic graph, it is always domain is belonging to real numbers and the range is also belonging to the real numbers. Why? Because we know that if we take a simple example of a cubic root is 2 and minus a cubic root is minus 2. So you have seen it there for positive values it is positive, for the negative values it is negative. So domain is what all real numbers of this and the range is also what all real numbers. So in simplify we can cite this, if domain is real number then the range of this graph is also real number, and if the domain is negative real number then the range of this graph is also negative real numbers there. Question number 11. F of x is equal to 1 over x minus 2. We know that for all the fractional inequalities, it is g of x over f of x, then f of x should not be equal to 0. So where it is f of x is equal to 1 over x minus 2, so domain of this function is x minus 2 is not equal to 0, this implies that x should not be equal to 2 there. And for the range of this function, this graph is always not equal to 2, so at 2 it is equal to infinity. So all real numbers except infinity. The range of this graph is all real numbers minus 0, because 0 will come when you put x equal to 2 in it. So all real numbers minus 0 is the values of this range of this graph. F of x is equal to 1 over x minus 2. Question number 12 now. F of x is equal to 1 over x minus 2 squared. Since it is in the denominator function and it is also in the form of this radical, so we know that for this domain, x minus 2 should only be greater than 0, not equal to 0 there. So domain will be x greater than 2 there. So the range of this graph will be all real numbers minus 0 to that value. Question number 13. F of x is equal to 1 plus 2 over x minus 1. So it is also in the fractional form, so domain should be equal to, in the denominator there is x minus 1, and that should be greater than 0 there. X is greater than 1. X minus 1 should not be equal to 0, or x should not be equal to 1, because it is in the fractional form of that 2 over x minus 1. So x minus 1 will play an important role in it. So x minus 1 should not be equal to 0. Domain is x is not equal to 1. And for this range, we can take the inverse of this function. Let's say y equal to f of x, then x is equal to f inverse of y. So you can make 1 plus 2 over x minus 1, or y minus 1 is equal to 2 over x minus 1, or x minus 1 is equal to 2 over y minus 1, or x is equal to 1 plus 2 over y minus 1. Since we have shown in the beginning that this is the domain, this is the range, when you take the inverse, this is the domain and this is the range. So y values is not equal to 1. So y is not equal to 1, or y minus 1 is not equal to 0. So this is the range of this graph here. And the 14th of this is the same situation. F of x is equal to 2 minus 1 over x plus 1. Again, it is in the fractional form of that inequalities. So x for domain, x plus 1 should not be equal to 0, or x should not be equal to minus 1. And for this range, let's take y as a subject, y is equal to 2 minus 1 over x plus 1, or 1 over x plus 1 is equal to 2 minus y or x plus 1 is equal to 1 over 2 minus y or x is equal to minus 1 plus 1 over 2 minus y. So for this domain, the value of y there is 2 minus y should not be equal to 0 or y should not be equal to 2. So the range of this graph is that y is not equal to 2 for this function here. Question number 15 now. F of x is equal to 1 over 2x minus 1 cubic root. So it is also in the form of the fraction, and we can write this thing as 2x minus 1 cubic root of that, which is equal to 1 over 2x minus 1 power 1 by 3. So for this domain, 2x minus 1, because it is in the fraction form, should not be equal to 0, or 2x should not be equal to 1, or x should not be equal to half. So this is the design possible there. When x is not equal to half, you can put any value of x in this equation, you can get the values of y to that. For the inverse of this function, now you can take, let's say, y equal to 1 over 2x minus 1 power 1 by 3, then 2x minus 1 power 1 by 3 is equal to 1 over y, or 2x minus 1 is equal to 1 over y cube, or 2x minus 1 is equal to 1 over y cube, or 2x is equal to 1 plus 1 over y cube, or x is equal to 1 over 2 plus 1 over 2y cube. So again, it is in a fractional form. So we have seen it there that when y is a function of x, then x is inverse function of y there. So domain is becoming range here, and this domain is becoming range of this function there. So the range of this, because it is in a fractional form, so y cube should not be equal to 0, or y is not equal to 0 for this function of this range of this graph. So whenever y is not equal to 0, you can get all the values of x for this values of this function. So these are the 15 examples we have taken it from this assignment, and we have solved out all for that domain and the range of all these functions.